Hey guys, I'm William from Terra, and today I'm going to be doing a short video on getting you set up with the Terra SDK for Python. So the Terra SDK for Python is our newly released replacement for Jigu, which had taken the place of the old Python SDK. And this one just matches the API spec for Terra.js and brings along compatibility features for Columbus 4, which includes smart contracts and things like message swaps. And so, um, so Jigu has been a bit out of date for quite a while. So we're happy to bring this up to date and release a new interface that kind of matches the consistency of Terra.js. So um, yeah, so let's get started. So the first thing I'd like to do is just show you around the doc site. This is at terraproject.github.io/terra SDK Python. Link in the description. So it is a comprehensive reference of everything available in the SDK, from usage guides over here to some reference guides, and the most interesting part is probably the core modules reference. So you can go into any of these modules and find things related to that module, um, grouped by, API messages and data elements. Just for example, I'm just gonna pick Oracle. So in Oracle, you can see that in the Oracle API, you can get various things from the LCD. You can get the aggregate pre-vote for a current validator, or the live one that they have currently submitted for the current vote period. You can get the current exchange rates. So that's the API. And the data includes the data objects associated, or the data objects that get returned from the LCD. So when you make these calls, the Terra SDK for Python will parse them and put them into a Python-friendly format, so that you don't need to parse the JSON yourself. So that's quite nice. And there's also functions that simplify things like creating the vote hash that's required for submitting pre-votes, as well as creating messages to broadcast your transaction. So in today's tutorial, I'm just going to teach you how to get set up with the Python SDK, and you know, take some time to explore some features with the LCD client. Do some live queries against the mainnet node and the testnet node, and we're gonna try out a couple messages and post some transactions to ourselves on the testnet. So to get started, let's hop over onto our terminal. I've loaded one right here. The first thing you'd want to do is install the Terra SDK for Python. Right. Well, I have already installed it. Let me just uninstall it and reinstall it. Yes. Okay. Well, the newest version, I think, is 0.10.0. So make sure you have that. Sorry about that. Let's just make sure we get the latest version. Install Terra SDK. Okay, awesome. Now, to follow along with this tutorial, I recommend you also get something called Jupyter. So Jupyter is is an interactive notebook shell for Python, and I think it's really good for learning new libraries, because you can edit the things that you put in, and then rerun those cells and see what happens when you change different variables. That just makes it easier to experiment with a new Python library. So install Jupyter. Okay, I have it installed, and then you're gonna want to run Jupyter Notebook, just like that. Okay, so just copy this address and hop back into your browser. Okay, now that you have your browser, and it's loaded with Jupyter, you want to create a new Python 3 notebook. And just to get set up with the Python SDK, let's just load up an LCD client, right? And I'm going to have mine connect to the mainnet node. So the mainnet node is available here at lcd.terra.dev, and the mainnet chain ID is Columbus4. So the first argument is the node URL with HTTP, and the second argument is the expected chain ID. So let's check if we have a proper connection. And as we can see, the network ID matches with our chain ID. So there's several things you can do. The first thing is in the Terra instance, or the LCD client instance, under the Terra variable, you can see that we have a bunch of things, and these correspond to the modules that I showed you earlier. So let's go to the Oracle, for example, and maybe get the Oracle parameters. As you can see, the Oracle parameters are just loaded off the blockchain, and these are live. So we can actually get the last request height. Let's try that. Last request height, right? So this is the result of our query, and this is the height that it corresponds to, right? So if I did this again, the last request height should change by 2, since around 15 seconds has passed. So yeah, this is how you know that this this information is live from the blockchain. So let's see. So there's several other things that you can find, but these functions are all collected under or organized under their corresponding modules. Like if you go to the treasury module, you can find with let's say you can get the parameters like I have been getting, but I can also be getting the tax rate, right? This is the tax rate. It's in a decimal format. And I can query the last request height again, just make sure that it's live. So the last request height, it's always changing. It always corresponds to the height at which the height for which the response corresponds to, if applicable. So so that's the basic functionality number 1 of the Terra SDK for Python, right? So it's just querying stuff from the blockchain, right? So I'm going to show you the second main functionality, which is to build and sign transactions and then broadcast them to the blockchain to affect state. So anytime you want to change the state of the blockchain, you have to create transactions. You have to sign those transactions and then broadcast them to the network, right? So in order to do so, we will start by making something called a key. So a key is basically an abstraction over something that can sign a transaction. And Terra SDK comes with a couple keys to get you started. But you can also build your own key if none of the solutions provided by the official Terra team or the community suffice for your needs. For instance, a lot of people are using ledgers to sign transactions, and you don't want to expose your private key in memory. Sometimes you want it to be decoupled from your program. So in those cases, you can build your custom key that interfaces with the ledger software by itself. But for this tutorial, I'm just going to use something called the mnemonic key, which is included with the Python SDK. So in order to do that, just import from key Terra SDK.key.mnemonic, and import mnemonic key. Right now we have mnemonic key, and how it works is you can use it simply by calling it. And if you give it no arguments, it will produce it will generate a random mnemonic, and you can see it like this: mnemonic. Right? We have a random mnemonic, and it's also generated for us an account, right? And it's also generated for us a private key in bytes, and that is what it will use to sign transactions, right? So it's very convenient. But if you want it to be repeatable, you can save this mnemonic and then just put it here such that we always have this one. We all like this mnemonic key will regenerate from this mnemonic and give us the proper account address. Now, if I create another mnemonic key, let's call this MK2, we can see that its mnemonic is going to be very different from the one that we generated before, right? So this is how you know that every time you create a mnemonic key, it generates a random mnemonic unless you provide a mnemonic, right? So there are other options for which you can configure mnemonic key, like the account and index and coin type. And that's available in the documentation. But to keep it simple, in this tutorial, I'm just going to use a simple mnemonic key with the one with the with the mnemonic just generated now, right? So because this is a new account, it has no funds. So I'm going to just use Tequila LCD now because I want to now create a. I want to try to use the testnet because I don't want to compromise some real funds. So I have this account address. Let's go to the faucet and just get some testnet funds. I'm just going to give myself some Luna. Okay, just wait for it. Okay, I got my Luna. Now I can try and see if that is passed by going to check my balance, terra.bank.balance, right? And I'm going to put in mk.ac address. And as you can see, I have my Luna. So let's see. This is 1,000 Luna. Let me give myself some UST as well, just to make it interesting. Okay. Now I have some UST. Okay, let's check this balance again. All right, so now we have some UST. And you may notice that when you use Terra SDK for Python, you get something like a coins object. If you notice, normally when you make a balance request on the against the LCD, you get something called coins, or like a JSON list of denom amount objects, right? But the cool thing about coins is that they're manipulable as a Python object, and they have a couple features that make them quite interesting or convenient to use. Like I can multiply it by 2, and as you can see, I get like I get twice as many coins, or I can like even divide them by like 17, right? And the Terra SDK for Python just makes it easy by giving me an abstraction over coins over the raw JSON list of denom amount pairs. So that makes it easier for me as a developer to work with these amounts. So when I get this from the blockchain, I can perform actions more easily, right? I can even get just the ULuna coin, right? It just gives me a coin with that, and I can get like the amount, right? So that's the cool thing about coins. It's just that it's a very convenient collections class. All right, so I'm going to be building a transaction that is going to send coins from MK to MK2. So let's print out MK address and mk2.ac address. All right, so from here to here. All right, so the message responsible for transferring coins between addresses, and these are native Terra assets. CW20 tokens are a different thing. For transferring native Terra assets between two accounts, you're going to want to use a message send. And the message send is available under the bank module. So in order to do so, let's create a message send. So it's from terrasdk.core.bank, import message send, right? And now we can create a send. Well, let's check out the help for the message send. see what we're working with. All right, so a message send from address first to address and amount, right? So we can do it two ways. We can do it like this. So let's do send equals message send. We can do MK, right? K2. And amount, we can do, so I want to send half my coins, right? So let's check out what send is. Right, there we go. So send now contains a message send that contains the message that says I want to transfer some coins from Terra 1E0S whatever to Terra 15H9CR whatever, right? With half the coins that I have in this account. All right, so now that we have the message send, we need to add that message send into a transaction. And Terra SDK has something called the wallet, which is available through your LCD client instance. Here in this instance, it's Terra. So you're going to want to make a wallet out of a key. And it's just going to make it easy to sign transactions, right? So you create a wallet, and then you do wallet.create and sign TX, right? And we're going to put in messages. So our messages is send. We're going to also put in a memo. Let's just say hello there. Right. Oops. Let's save it in a TX. Right. Let's inspect this TX. Okay, as we can see, we have the messages. And we also have this fee, which is interesting because we didn't provide a fee here. And because we didn't provide a fee here, the blockchain will automatically try to estimate that for us. Or the Terra SDK will try to automatically estimate for us by simulating it inside the node. So before it creates the transaction with the signature, it estimates the fee by sending the bare transaction and seeing how much gas it would take, right? And the automatic fee estimation can be parameterized, and we'll see in a bit. But I also want to show how it automatically signs with the private key in the mnemonic key, right? So if we edit this memo a bit, we'll see that the signature is very different because the contents of this transactions have changed. And a cryptographic signature changes significantly if the contents change. So so it's fairly convenient what Wallet provides, where you can create and build an entire transaction and sign it in one single step. So this kind of lets you focus as an application developer on which type of messages to include, such that you can affect the state of the blockchain without thinking too much about which key management things you're going to use, or how you're going to format the transaction properly or simulate the transaction to estimate the gas. The Terra SDK does that all for you. So once you have the transaction and it's a signed transaction, you can try to broadcast it. So we're going to do terra.tx.broadcast, and let's just save it in a result. Right. Okay. Well, that's a bad sign that it came back so quickly. And as we can see, there were insufficient fees, right? So let's try this again. There are insufficient fees probably because we didn't set the gas estimation parameters correctly. So let's try that. So gas prices. So gas prices expects things of type coin, but you don't have to. Coins. You don't have to always. You don't have to always create a coins object by yourself. There's many functions that get coerced into a coins object, and you can use a string, right? And that automatically gets coerced to a coin. So let's just use 1 Uluna, right, as our gas prices, and let's see, gas adjustment. Let's set that to 1.5, and let's see what is our new gas, or what's our new fee. Okay, our new fee is here's the amount. It's interesting because the new fee comes as two denominations, and that's because by default, the fee estimation will use all of the denominations for which the signing key has a balance. And remember, we gave ourselves a bit of Luna and a bit of UUSD. I just want to limit those to let's just pay in Luna. So here I limited my fee in Luna. So you use the denoms parameter to limit the fee estimation, like what which denoms to use. And I just want to pay in ULuna, so I put the denoms parameter like that. All right, so now that we have the TX, let's try to broadcast it now. Okay, still seems insufficient. All right, maybe bump it up. Well, let's try it with USD. Hold on. Okay. Well, apparently it requires some UUSD. Because I'm sending UUSD, and it requires some tax. So I have to put that tax in, unfortunately, in the transaction. You can't just pay in ULuna. So I have some tax. All right. So now, as you can see, it blocked for about a couple seconds, which is a good sign for us because it normally, if you use this method, broadcast TX, it will wait or it will block until your transaction is included into a block. And now we can see all the information about our transaction, including the logs in the events, right there. But it's kind of hard to see here. Let's try to look at it in a browser. So we go to Terra Finder and post it on transaction, change the network. All right, here we go. So here's the transaction, and I've sent some like 500 Luna and 2,500 USD. Right, so it looks good. So from this address, from this address to this address, looks good. So we've successfully created our first transaction and broadcasted it. So let's try another transaction with a different message. So let's try instead of bank, let's do a message swap just to try out the salient feature of the Terra chain, where you can swap Luna to Terra and Terra to Luna, or Terra to Terra. So you build a swap message. Let's just check out what the swap message requires first. Oops. Okay, so we first need a trader, offer coin, and ask denom, right? An offer coin is a coin, but it also takes in a string which get coerced into a coin. So let's do swap. So what I want to do is I want to swap. So I'm starting from this address. I want to swap. Let's try to let's do 1 UST to Luna. Right, let's check out. All right, let's do swap, and so we don't need a memo, but we do need the gas prices. I'm just gonna keep this, even though it's pretty high gas. I create the TX. Now I have this swap, and now let's broadcast it. It's a good sign because it's taking long. All right, let's check out the TX hash. So, oops. All right, cool. Let's see how much we get out. So here's the swap fee, and here's the swap. So actually, I got one. Let's see, like less than 1 Luna, because Luna is so expensive now. All right, so that's basically the basics of how you can um, perform the main operations that you'd require when you're working with the Terra SDK for Python. There's only, even though the documentation's a little daunting because there's so much you can do, there are only two main things. They're using the API to get information about the blockchain and creating transactions, uh, interacting with the different modules, right? I can go into the, let's say, governance, uh, and say I wanted to create some sort of bot that just tracked whenever there was a new proposal. I could use the API, and then I could automatically um, vote for that proposal using a message vote, right? I'd create that message, put that in a transaction, and then submit it to the blockchain with the method that I showed you. So that's that. So we're really excited to, um, have a chance to like just release this overdue Python SDK. But we're really excited to see what you'll be building, especially as we've released a couple smart contracts such as Mirror and the upcoming Anchor, and on the docs you're going to find a guide on how to work with smart contracts and do other things with the SDK that I haven't gone into. But yeah, I'm really excited to see the next phase of Terra development. And yeah, and if you need help, we'll be ready to give you some support on the Terra Discord. So catch you next time, and really excited to see what you're going to build.